All right, today you'll be taking the solar system and gravity quiz. Question 1. A student writes the following in his notes. The object in space is much bigger than Earth. It is mostly gas and is generally round. It has many moons and is closer than Saturn to Earth. Which of these is the student describing? The Sun, Jupiter, Venus, or Mars? Question 2. A rocky object that measures 50 miles across in space. It rotates once every 18 hours. The object is 3 times further from the Sun than Earth is. The rocky object is most likely Saturn, Pluto, Mercury, an asteroid. Question 3. Students are working on a scale model of the solar system. They are planning to use a table tennis ping pong ball to show Earth. Which of the following would be best choice to model Jupiter? A basketball, a baseball, a golf ball, or a softball? Question 4. Which of these is an accurate conclusion that can be drawn from this data? So look at the data table. Planets from the Sun are usually larger. Planets far from the Sun are close to the size of Earth, or planets close to the Sun are the same size. Question 5. You can find all of these in the solar system except moons, planets, galaxies, asteroids. Question 6. The following image is from a newly discovered solar system. Based on your knowledge of our solar system, which planet would take the least amount of time to orbit the star? Planet A, Planet B, Planet C, or Planet D? Question 7. The following chart was placed in a student's journal. What criteria did the student use to separate the two sets of data, or sets of planets? Planets with and without moons, planets with water and planets without water, planets with atmosphere and planets without atmospheres, terrestrial or rocky planets, and gas giants. So how did they separate the two sets of planets? Question 8. The table below shows the approximate percentages of gases in the atmospheres of Jupiter, Saturn, Uranus, and Neptune. Not all sets add up to exactly 100%. Using the table, which planets have the most similar atmospheres? Uranus and Neptune, Saturn and Uranus, Jupiter and Saturn, or Jupiter and Neptune? Question 9. Many of the planets in the solar system have orbits of similar shapes, but they orbit at very different speeds. Why do planets orbit at different speeds? Planets are kept in their orbits by tension force, which is affected by the atmospheric pressure of a planet. Planets are kept in their orbits by electromagnetic force, which is affected by the diameter of a planet. Planets are kept in their orbits by friction, which is affected by the temperature of a planet. Or planets are kept in their orbits by gravity, which is affected by the mass of a planet. Question 10. Jupiter takes 4,332 days to orbit the Sun, while Mercury takes 88 days. Why is Mercury able to orbit the Sun more quickly than Jupiter? Mercury orbits much closer than Jupiter, so it feels the Sun's magnetic field more intensely. Mercury orbits much closer than Jupiter, so it feels the Sun's gravity more intensely. Mercury has more moons than Jupiter, which causes Mercury to orbit faster, or Mercury has more mass than Jupiter, which causes Mercury to orbit faster. Question 11. The planets of the solar system travel in orbits, but at different speeds. The reason that they travel at different speeds is that the Sun does not exert tension on any of the objects or any of the planets, exerts a different amount of air resistance on each planet, exerts a different amount of gravitational force on each planet, or does not exert electromagnetic force on any of the planets. And finally, question 12. Jupiter takes 4,332 days to orbit the Sun, while Mercury takes 88 days. Why is Mercury able to orbit the Sun more quickly than Jupiter? Jupiter has greater inertia than Mercury. Mercury has greater inertia than Jupiter. The Sun exerts weaker gravitational pull on Mercury than does Jupiter, or the Sun exerts a stronger gravitational pull on Mercury than it does on Jupiter.